Hello aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from Vssc Scientific Assistant Physics exam. Without any further delay, let's get started.
The first question is, an N-type and a P-type silicon can be obtained by dash. For an N-type semiconductor, it is created by doping a group 4 element like silicon with a pentavalent impurity such as phosphorus. So the extra electron from the impurity contributes to conduction. And for a P-type semiconductor, it is created by doping silicon with a trivalent impurity such as boron. This creates a hole which acts as a positive charge carrier. So to obtain N-type and a P-type silicon, we must use phosphorus and boron. So the answer is option C. Next question is, at 0 Kelvin the intrinsic semiconductor behaves as dash. At absolute zero temperature, an intrinsic semiconductor behaves like a perfect insulator because there is no thermal energy available for electrons to jump from valence band to conduction band. So there is no free charge carriers to conduct electricity. So we can say that it behaves as a perfect insulator. The next question is, a current carrying wire is stretched horizontal and carrying current along west to east. The direction of magnetic field 1 meter above the wire will be dash. We know that the direction of a magnetic field can be found out using right hand thumb rule. By this rule, the thumb denotes the direction of current, the curled fingers denotes the direction of the magnetic field. And here it is given that the direction of the current carrying wire is from west to east, so that the direction of the magnetic field is from south to north. Next question is, it is possible to observe total internal reflection when a ray of light travels from dash. For total internal reflection, two conditions need to be satisfied. One is the light should travel from denser medium to the rarer medium. And the second is the angle of incidence is greater than the critical angle. So here in the given options, the refractive indexes for air, water and glass can be taken as 1.003, 1.33 and 1.5 respectively. In the option A, it is given that air to water, that is rarer to denser medium, and option B says air to glass, that is also rarer to denser medium. Then option C says water to glass, it is also rarer to denser medium. Then option D says glass to water, that is denser to rarer medium. So option D is the only option that satisfies the condition for total internal reflection. So the answer is option D. Next question is, the most important contributor to global warming is dash. So the primary cause of the global warming is the increase in the greenhouse gases, and also due to human activities like burning fossil fuels, it causes the global warming. The option that matches is the increase in the greenhouse gases. So the answer is increase in the greenhouse gases. Next question is, the temperature of a given amount of water is slowly increased from 275 to 288 Kelvin. Among the following temperature, the volume occupied by the water will be minimum at dash. We know water has an anomalous expansion. That means it can reach the maximum density and minimum volume at 4 degrees Celsius. That means 277 Kelvin. Here it is given that the temperature is increased from 275 to 288. That means 275 is below 277 Kelvin and 288 Kelvin is above 277 Kelvin. That means the volume of the water will decrease until it reaches 277 Kelvin and then it starts to increase again. So the minimum volume will occur at 277 Kelvin. So the answer is 277 Kelvin. Next question is, an electric fan is switched on in a closed room. The air in the room will be dash. When a fan is switched on, the electrical energy gets converted to heat energy. This increases the kinetic energy. When the kinetic energy increases, the temperature increases. That means the air molecules get heated. Although the fan makes people feel cooler, but it actually doesn't lower their room temperature. So the air molecules get heated is the right answer. Next question is, in nuclear fusion, 1 gram hydrogen is converted into 0.993 gram helium. the energy released is dash. So here the change in the mass is equal to 1 gram minus 0.993 gram, that is equal to 0.007 gram. So this is equal to 7 into 10 power minus 6 kilogram. So E is equal to delta mc square, that is equal to 7 into 10 power minus 6 into 3 into 10 power 8 the whole square, and this is equal to 7 into 10 power minus 6 into 9 into 10 power 16, and this is equal to 63 into 10 power 10, that is equal to 6.3 into 10 power 11 joule. So this is the answer. Next question is, the electromagnetic waves of frequency 12 megahertz are emitted by a radio station. Their wavelength will be dash. Here f is equal to 12 megahertz, that is equal to 12 megahertz into 1000000 divided by 1 megahertz, and this is equal to 120000000 second raised to minus 1. Here lambda is equal to c by f, that is equal to 3 into 10 power 8 divided by 120000000 second raised to minus 1, and this is equal to 25 meter. Next question is, in a faulty thermometer, the 0 degree Celsius mark corresponds to the actual temperature of 5 degrees Celsius, and the 100 degrees Celsius mark to actual temperature of 95 degrees Celsius. The temperature of the body measured by this thermometer is 60 degrees Celsius. Assuming linearity, what is the true temperature of the body? So here T true is equal to m into T faulty plus C. This is equation number 1. When T faulty is equal to 0 degree Celsius, then T true is equal to 5 degree Celsius. This is equation number 2. And when T faulty is equal to 100 degrees Celsius, T true is equal to 95 degree Celsius. This is equation number 3. Equation number 2 and equation number 3 is given itself in the question. So substituting the value of 2 in 1, we can write 5 is equal to m into 0 plus c, that is equal to c is equal to 5. Then substituting the value of 3 in 1, we can write 95 is equal to m into 100 plus c. Substituting the value of c here, we can write m into 100 plus 5, that is m is equal to 0.9. So T true is equal to 0.9 into T faulty plus 5. Given that T faulty is equal to 60 degrees Celsius, then T true is equal to 0.9 into 60 plus 5, that is equal to 59 degrees Celsius. So this is the answer. Next question is, which one of the following statement is not correct? At 1 atm pressure, the pure water boils at approximately 100 degrees Celsius, that is 373 Kelvin. At this temperature, the vapor pressure of water is 760 mmHg, and this is equal to 1 atm. So the option A is correct statement. If the external pressure is lower than 1 atm, then the water will boil at a temperature lower than 373 Kelvin. So option B is also a correct statement. Then if the external pressure is higher than 1 atm, then water will require a higher temperature to reach that water vapor pressure, so that it will boil at a temperature higher than 373 Kelvin. So the option C is also a correct statement. But the option D says that the water boils below 373 Kelvin at 1.22 atm. Since 1.22 atm is greater than 1 atm pressure, then the boiling point would actually be above 373 Kelvin. So the incorrect statement is option D. The next question is, the distance travelled by a body falling freely from the rest in the first, second and third seconds are in the ratio. For a freely falling body, the initial velocity is u is equal to 0. And we know that the distance travelled is given by the equation s is equal to ut plus half at square. Here a is equal to g. So s is equal to half gt square. Here the distance travelled after t equal to 1 second is s1 is equal to half into g into 1 square, that is equal to 1 by 2 g. The distance traveled after t equal to 2 second is s2 is equal to half into g into 2 square, that is equal to half into g into 4, that is equal to 2g. Similarly, the distance after t equal to 3 second is s3 is equal to half into g into 3 square, that is equal to half into g into 9, that is equal to 4.5 g. Next, we need to find the distance traveled during the first, second and third seconds. So here the distance in the first second is d1 is equal to s1 minus s0, where s0 is the distance that traveled after 0 seconds. So this is equal to 1 by 2 into g minus 0, this is equal to half into g. Then the distance that covered in the second is d2 is equal to s2 minus s1, and this is equal to 2g minus half into g, and this is equal to 3 by 2g. Then the distance that traveled during the third second is d3 is equal to s3 minus s2, and this is equal to 4.5g minus 2g, that is equal to 5 by 2g. The ratio of the distance traveled in the first, second and third seconds is d1 is to d2 is to d3. So d1 is to d2 is to d3 is equal to 1 by 2g is to 3 by 2g is to 5 by 2g. Solving this, we can write the ratio as 1 is to 3 is to 5. Actually, this is known as the Galileo's law of odd numbers for freely falling bodies. So this is the ratio. The next question is, three positive charge of equal magnitude Q are placed at the vertices of an equilateral triangle of side 2 cm. What is the magnitude of the force acting on a positive charge of magnitude Q placed at the centroid of the triangle? We know centroid is a point that is equidistant from all the three vertices. So here three positive charges of equal magnitude Q is placed at the vertices of an equilateral triangle, and a capital Q is placed at the centroid. So at the centroid there experiences three forces of equal magnitude. Three forces vectors are separated by an angle of 120 degree, but these forces cancel out each other due to the perfect symmetry, so that the magnitude of the force that acting at this centroid is 0. So the answer is 0. The next question is, a potential function is defined as v of x is equal to 0 for x less than 0 is equal to v0 for 0 less than x less than a is equal to 0 for x greater than a. It is an example of dash. So this potential function describes a constant potential v0 between x is equal to 0 and x is equal to a with 0 potential elsewhere. So this represents a rectangular potential barrier. So this is the answer. Next question is, the mean free path of the molecule is dash. We know mean free path of a gas molecule is lambda is equal to kBt divided by root 2 pi d square p. That is the lambda, that means the mean free path is inversely proportional to pressure. So the answer is option A. Next question is, two magnetic lines of force dash. We know the magnetic field lines never intersect each other. This is because we know that if they intersect each other, it would imply that there would be two directions of magnetic field at a single point. This is actually not possible, because if we place a compass needle there, it would have to give two directions simultaneously. This is not possible. So two magnetic lines of force can never intersect. Next question is, the average value of the function f of x is equal to 4x cube in the interval between 1 to 3 is dash. The average value of a function can be found out by the equation f average is equal to 1 by b minus a integral over a to b f of x dx. So here the interval given is 1 to 3. That is, this is equal to 1 by 3 minus 1 integral over 1 to 3 4x cube dx, and this is equal to 1 by 2 integral over 1 to 3 4x cube dx, and this is equal to x raised to 4 by 2, where the limit starts from 1 to 3. This is equal to 80 by 2, and this is equal to 40. So the answer is 40. The next question is two stars A and B emit maximum radiation at 3500 Armstrong and 4900 Armstrong respectively. The temperature of two stars A and B are in the ratio dash. So here it is given that lambda A is equal to 3500 Armstrong, lambda B is equal to 4900 Armstrong, and we know that lambda max into T is equal to a constant, that is lambda A TA is equal to lambda B TB, that is TA by TB is equal to lambda B by lambda A, that is equal to 4900 divided by 3500, and this is equal to 7 by 5, that is TA is to TB is in the ratio 7 is to 5. So the answer is 7 is to 5. Next question is anemometer is an instrument used for measuring dash. It is an instrument to measure wind speed and wind pressure. So it is a crucial tool for studying weather patterns. So the name comes from the Greek word anemos meaning wind. So the answer is wind speed. The next question is the percentage of oxygen in the atmosphere is approximately dash. Earth atmosphere contains 78% of nitrogen and 21% of oxygen. The remaining percentage includes argon, carbon dioxide and other gases in the trace amount. So the answer is 21%. The next question is when the ray of sun passes through the glass prism, the color of light undergoing the minimum deviation is dash. When white light passes through the glass prism, it disperses into its constituent colors, that is picture. So the deviation produced by the prism is inversely proportional to the wavelength of the light. The red light has the longest wavelength, so it undergoes minimum deviation. The white light has the shortest wavelength, it undergoes maximum deviation. So here the answer is red. The next question is the decimal system equivalent of the binary number 1001 is dash. So here 1001 can be written as this is equal to 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 0 into 2 power 1 plus 1 into 2 power 0, and this is equal to 1 into 8 plus 0 into 4 plus 0 into 2 plus 1 into 1, and this is equal to 9. So this binary digit is equal to 9 in the decimal number system. The next question is a shaft of diameter 40 cm is tightly fit into the center of a pulley of diameter 2 meter along its axis so that the system rotates uniformly. What is the ratio of the linear velocities on the rim of the pulley and on the outer surface of the shaft? What is the corresponding ratio of the centripetal acceleration? Here P denotes pulley and S denotes shaft. So ds is the diameter of shaft and this is equal to 40 centimeter and this is equal to 0.4 meter, and dp is the diameter of pulley and this is equal to 2 meter. The radius of shaft is equal to 0.2 meter and radius of pulley is equal to 1 meter. So the velocity v is equal to r omega, that is vp by vs is equal to omega rp divided by omega rs, and this is equal to rp divided by rs. This is equal to 1 divided by 0.2 and this is equal to 5. So the centripetal acceleration AC is equal to omega square r. So ACP divided by ACS is equal to omega square RP divided by omega square RS. This is equal to RP by RS is equal to 1 divided by 0.2 and this is equal to 5. So the answer is 5 and 5. The next question is if f of x is equal to x sec x, then f of 0 is dash. We know f of x is equal to x sec x, and if we substitute the value of x is equal to 0 here, we can write f of 0 is equal to 0 into sec 0. We know sec 0 is equal to 1 by cos 0, this is equal to 1 by 1 and this is equal to 1. So f of 0 is equal to 0 into 1 and this is equal to 0. So the answer is 0. The next question is if A is a symmetric matrix, then A transpose is equal to dash. Symmetric matrix is defined as a square matrix which satisfies the condition A transpose equal to A. So the answer is A. Next question is which of the following statement is incorrect? We know alpha particle is a helium nuclei with a positive charge of +2. Their movement is affected by the electric and the magnetic field, and the energy of the alpha particle emitted by the specific radiative isotope during the alpha decay is discrete. So the statement given in the option C is considered as incorrect. So the answer is option C. Next question is the radioactive constant of an element is 1.386 into 10 power minus 4 per year. Its half-life period is dash. So here the half-life can be defined by the equation T half is equal to ln2 by lambda. We know lambda is equal to 1.386 into 10 power minus 4. So T half is equal to, we know ln2 is equal to 0.693. That is T half is equal to 0.693 divided by 1.386 into 10 power minus 4. And this is equal to 0.693 divided by 0.0001386, and this is equal to 5000 years. So this is the answer. The next question is, for fused silica, the variation of real part of refractive index as a function of wavelength in the visible band is as follows. For most transparent materials including fused silica, the refractive index decreases as a wavelength increases. So this phenomena is known as normal dispersion. So here the answer is the refractive index decreases with the increase in wavelength. That means it is inversely related. The next question is, two straight long wires are set parallel to each other. Each carries a current I in the same direction and the separation between them is 2R. The intensity of the magnetic field at a distance R between the two wires is dash. The direction of the magnetic field can be found out using right hand rule, and we know that for a straight line wire the magnetic field is equal to mu 0 I by 2 pi r. At a distance r from each wire the magnitudes are equal, and this is equal to mu 0 I by 2 pi r. Here we know that the direction of the magnetic field is in the opposite direction. So we can write B net is equal to B1 minus B2. That is mu 0 I by 2 pi r minus mu 0 I by 2 pi r is equal to 0. So the intensity of the magnetic field at a distance r between the two wires is 0. So the answer is option D. The next question is, the mean energy per molecule of a polyatomic gas with n degrees of freedom is given by dash. We know by the law of equipartition theorem, the mean energy per molecule of a gas is given by F by 2 into kT, where F is the number of degrees of freedom, K is the Boltzmann constant, and T is the temperature. So here in this problem it is given that the number of degrees of freedom is n. So the mean energy per molecule is n by 2 into kT. So this is the answer, that is nkt by 2 is the answer. The next question is, the root mean square velocity of oxygen at a given atmosphere pressure and at 0 degrees Celsius is dash. We know the root mean square velocity Vrms is equal to square root over 3RT by m. And here air is composed of oxygen and nitrogen with an average molar mass of approximately 29 gram per mole. Since the RMS velocity is the inversely proportional to the square root of molar mass, a gas with higher molar mass will have the lower RMS velocity at the same temperature. So as the molar mass of oxygen is greater than the molar mass of air, so the RMS velocity of oxygen will be less than that of the air at the same temperature. That means the RMS velocity of oxygen at 0 degrees Celsius is approximately 461 meter per second. So here the answer is option B. The next question is, the limit of resolution of an optic instrument arises on account of dash. The resolving power of an optical instrument is limited by the phenomena of diffraction of the light waves at the aperture of the instrument. The diffraction causes the image of a point source to be diffraction pattern rather than a single point, which limits the ability to distinguish between two closely spaced objects. So the answer is diffraction. The next question is, the correct statement about the isothermal processes d2 and du are the changes in the temperature and the internal energy. Q is the heat energy and W is the work done. We know for an isothermal process temperature is constant. That means the change in temperature dt is equal to 0. So for an ideal gas, the internal energy du is a function of temperature only. So if dt is equal to 0, then du is equal to 0. So by the first law of thermodynamics, the change in the internal energy is given by du is equal to dq minus dw. Here du is equal to 0. That means dq is equal to dw, that is q is equal to w. So all the statements are correct for an isothermal process involving an ideal gas. So the answer is all of the above. The next question is the limit extends to 0, x square minus 100 divided by 2x minus 20. Here we need to find the value of limit extends to 10, x square minus 100 divided by 2x minus 20. The numerator is a difference of square, that is x square minus 10 square is equal to x minus 10 into x plus 10. So this can be rewritten like this. And also denominator can be factored by taking out a common factor of 2. That is 2x minus 20 is equal to 2 into x minus 20. So this can be rewritten as limit x tends to 10, x minus 10, x plus 10 divided by 2 into x minus 10. Since x tends to 10, x not equal to 10. So the common factor x minus 10 can be cancelled from the numerator and the denominator. That means limit x tends to 10, x plus 10 divided by 2. So substituting the value of x is equal to 10, here we can write 10 plus 10 by 2, that is equal to 20 by 2. So the answer is 10. The next question is, if a radiation of wavelength lambda is incident on particle having size less than lambda by 100, the scattering cross section of the individual scatterers will vary as dash. We know by Rayleigh scattering theory, the intensity is inversely proportional to the fourth power of wavelength, and the scattering cross-section sigma is directly proportional to the intensity of the scattering radiation. So we can write sigma is proportional to I scattering divided by I incident, and this is proportional to 1 by lambda raised to 4. That means the scattering cross-section is proportional to lambda raised to minus 4. So the answer is lambda raised to minus 4. The next question is, if the radius of the earth is reduced by half, the earth's surface temperature will dash. The earth's surface temperature is determined by the balance between incoming solar radiation and the outgoing thermal radiation, a process described by the Stefan-Boltzmann law and the greenhouse effect. The radius of the earth affects its surface area and volume but doesn't change the amount of solar radiation per unit area received from the sun, nor the fundamental physical laws governing the energy balance. Assuming the Earth mass and the atmospheric composition remains unchanged, the reducing the radius would only make the planet denser and alter its gravitational properties. So the surface temperature, however, it is an intensive property that depends upon the energy flux remains constant. So here the answer is it remains the same. The next question is, a satellite is moving around the earth with a speed v in a circular orbit of radius r. If the orbit radius is decreased by 1%, its speed will dash. We know v is equal to square root over g m by r, that is v is proportional to r raised to minus half. That is delta v by v is equal to minus 1 by 2 delta r by r. Here it is given that delta r by r is equal to minus 0.01. That is delta v by v is equal to minus half into minus 0.01, and this is equal to 0.005. So the positive value indicates that there is an increase of 0.5 percentage. The next question is, the Fraunhofer lines in the solar spectrum are explained by dash. We know the Fraunhofer lines are the dark absorption lines in the sun's continuous spectrum, and according to Kirchhoff's law of spectroscopy, a cool gas placed between the observer and the continuous spectrum source will absorb light at specific wavelength, producing these dark lines. The sun's cooler outer atmosphere absorbs specific wavelength of the continuous light emitted by the hot inner core, resulting in the observed Fraunhofer lines. So here the answer is Kirchhoff law. The next question is a particle performing simple harmonic motion and passing through the mean position has dash. In the SHM, the total energy is conserved. So here the potential energy is maximum at the extreme position and minimum at the mean position, and the kinetic energy is minimum at the extreme position and maximum at the mean position. Therefore, when a particle passes through the mean position, its potential energy is converted entirely into the kinetic energy, resulting in the maximum kinetic energy. So the answer is maximum kinetic energy. Next question is the Coriolis force on Earth arises from dash. Coriolis force is an apparent force that results from Earth rotation. It causes moving object to be deflected to the right in the northern hemisphere and to left in southern hemisphere. This phenomena is a direct consequence of the planet's spin on its axis, not its revolution around the sun changes in atmospheric pressure or its magnetic field. The next question is a force F is a conservative force if it's dash. The conservative force field F is the one that can be expressed as a negative gradient of the scalar potential function, that is F is equal to minus del V. So here the curl of that force del cross F is equal to 0. So the answer is curl is 0. Next question is a planet is at a distance of 1000 million kilometer from an observer and subtends an angle of 0.01 degree. The approximate diameter of the planet will be dash. Here the theta given as 0.01 degree. Converting it to radians, we can write 0.01 into pi by 180, and that is equal to 0.0001745 radians. So here the diameter d is equal to capital D into theta, where capital D is the distance to the planet. So here d is given as 1000 million kilometer. So small d is equal to 1000 into 0.0001745, and this is equal to 0.1745 million kilometers. So the answer is 0.17 million kilometer. Next question is if E and H represent the electric and magnetic field, the Poynting vector S of an electromagnetic wave is given by dash. So here the Poynting vector can be denoted by S. It represents the directional energy flux density, that is the power per unit area of the electromagnetic field. So it is defined as the cross product of electric field intensity E and the magnetic field intensity H, that is S is equal to E cross H. Next question is the lattice vibration are quantized in terms of dash. Lattice vibration, which are the collective oscillations of atoms in a crystal lattice, are quantized into discrete units of energy called phonons. And phonons are considered as the quasi-particles in condensed matter physics and are analogous to how photons are the quanta of electromagnetic radiation. So the answer is phonons. Next question is which of the following wires of the same material will have the highest resistance? We know R is equal to rho L by A and A is equal to pi R square. So R is proportional to L by R square. So from this we can understand that to have a higher resistance, the wire should have the longest length and the smallest radius. So comparing all the options, we understood that the option B has the greatest length, that is 80 meter, and the smallest radius, that is 1 millimeter among all these choices. So the answer is option B. The next question is the term God's particle refers to dash. So God's particle is popularly, it is a nickname for Higgs boson. It is an elementary particle in the standard model of particle physics. So here the answer is Higgs boson.
Next question is, consider a simple hydrogen atom wherein single electron orbits around a proton. Find out the instantaneous linear velocity needed to sustain the electron in the orbit. Here the velocity Vn is equal to Zd square by 2nh epsilon 0, and this is equal to Zc alpha by n, where alpha is a fine structure constant, that is alpha is equal to 1 by 137, and here Z is equal to 1 and n is equal to 1 for first orbit, that is V is equal to 1 into 3 into 10 power 8 into 1 by 137, this is equal to 2.2 into 10 power 6 meter per second. Next question is, an electron is ejected with a velocity v horizontally into a vertical electric field E. Assume the mass of the electron as m and charge E. What is the horizontal acceleration and the trajectory in the vertical plane? Here electric field is vertical and the initial velocity is horizontal. So the electric force acts only in the vertical direction, causing the vertical acceleration. There is no force in the horizontal direction. So we know F is equal to ma. So in the horizontal direction, F horizontal is equal to 0. That means A horizontal is equal to 0. So in the vertical direction, F is equal to F vertical, that is equal to EE, resulting in a constant vertical acceleration, that is A vertical is equal to EE by m. So in the horizontal direction there is zero acceleration, that means there is a constant velocity, and in the vertical direction there is a free fall, that means there is a constant acceleration. So the combination of this gives a parabolic trajectory. Next question is, a capacitor of 5 microfarad is charged to a potential difference of 250 watt. After isolating it from the source, another uncharged capacitor of 10 microfarad is connected in parallel to it. What is the potential difference across the new combination of capacitors? So here C1 is equal to 5 microfarad, V1 is equal to 250 watt. So Q1 is equal to C1 V1, that is equal to 5 into 10 power minus 6 into 250, and this is equal to 1250 mu C. So here as the initial charge on the second capacitor is 0, we can write Q2 is equal to 0. So Q total is equal to Q1 plus Q2, and this is equal to 1250 mu C plus 0 mu C. This is equal to 1250 mu C. So C equivalent is equal to C1 plus C2, this is equal to 5 plus 10, and this is equal to 15 microfarad. So V final is equal to Q final divided by C equivalent. This is equal to 1250 mu C divided by 15 microfarad, and this is equal to 83.33 volt. Next question is, an electric kettle draws a current of 5 ampere when connected to 220 volt. How long it will take to boil half a liter of water from room temperature? Here power P is equal to VI, this is equal to 220 into 5, this is equal to 1100 watt. So M is equal to 0.5 kilogram, that is equal to 500 gram. Here temperature change delta T is equal to Tf minus Ti, this is equal to 100 degrees Celsius minus 25 degrees Celsius, this is equal to 75 degrees Celsius. Q is equal to MC delta J, that is equal to 500 into 4186 into 75, this is equal to 156975 joule. So Q is equal to P into T. So T is equal to Q by P, that is 156975 divided by 1100 is equal to 142.7 second, that is 2 minute 22.7 second, that is 2 minute 23 second. Next question is, a series RL circuit and a series RC circuit have same resistance R have equal time constant. If L is equal to 12 H and C is equal to 3 microfarad, what is the value of R and the time constant? So here the time constant tau RL is equal to L by R for RL circuit, and tau RC is equal to RC for RC circuit. Here L is equal to 12 H, C is equal to 3 microfarad, this is equal to 3 into 10 power minus 6 farad. So tau RL is equal to tau RC. So L by R is equal to RC, that is R square is equal to L by C, that is R square is equal to 12 divided by 3 into 10 power minus 6, that is equal to 4 into 10 power 6. So R is equal to 2 into 10 power 3 ohm, that is 2 kilo ohm. Here tau RC is equal to RC, that is equal to 2 into 10 power 3 into 3 into 10 power minus 6 farad, that is equal to 6 into 10 power minus 3s, that is 6 milliseconds. Next question is, the liquid helium is stored inside a cryostat container. It is then boiled by using an immersion electric heater using 10 volt. If the heater works for 45 minutes, how much of the liquid helium might have converted to vapor? Given that the latent heat of vaporization of helium is 20.9 kilojoule per kg and the boiling point is 4.2 Kelvin. So here P is equal to 10 watt, T is equal to 45 minute into 60, this is equal to 2700 second. And here Q is equal to P into T, that is 10 into 2700, this is equal to 27000 joule. So latent heat of vaporization LV is equal to 20.9 kilojoule per kg, that is equal to 20.9 into 1000, this is equal to 20900 joule per kg. So Q is equal to MLV, that is M is equal to Q by LV, that is equal to 27000 divided by 20900, that is equal to 1.29 kg. Next question is, a lead pellet flying with the velocity of 100 meter per second passes a wall following which its velocity becomes 60 meter per second. What will be the increase in the temperature of the pellet if 40% of its lost kinetic energy is spent for heating the pellet? The specific heat of the lead is 125 joule per kg Kelvin. Here kinetic energy initial is equal to half m into 100 square, this is equal to 5000 mj. Kinetic energy final is equal to half m into 60 square, this is equal to 1800 mj. So change in kinetic energy is equal to 5000 minus 1800, this is equal to 3200 mj. So Q is equal to 0.40 into delta Ke, that is equal to 0.40 into 3200 m, this is equal to 1280 mj. And we know Q is equal to mc delta T, this is equal to 1280 m, that is m into 125 joule per kg Kelvin into delta T is equal to 1280 m. Mass get cancelled, so we can write delta T is equal to 1280 divided by 125, that is equal to 10.24 Kelvin. As it is the temperature change, we can directly write this is equal to 10.24 degrees Celsius. The next question is, the resistance of an ammeter is 13 ohm and its scale is graduated from a maximum current of 100 ampere. After an additional shunt has been connected, it becomes possible to measure a maximum current of 750 ampere by this instrument. What is the resistance of the additional shunt? So here Rg is equal to, that means resistance of galvanometer is 13 ohm, and Ig is equal to 100 ampere and I is equal to 750 ampere. So Is, that is the current through shunt, is equal to I minus Ig, this is equal to 750 minus 100, this is equal to 650 ampere. Then for a parallel combination, we can write Vg is equal to Vs, that is Ig Rg is equal to Is S, that is S is equal to Ig Rg divided by Is, that is equal to 100 into 13 divided by 650, that is equal to 2 ohm. The next question is, the voltage of an alternating current is given by the equation V of t is equal to 100 sin 20 pi t volts. The values of the maximum voltage, RMS voltage and frequency respectively are dash. We know V of t is equal to V max into sin omega t, and here it is given that V of t is equal to 100 sin of 20 pi t. So V max is equal to 100 volt. So Vrms is equal to V max by root 2. This is equal to 100 divided by root 2. This is equal to 70.7 volt. We know omega is equal to 2 pi f, that is equal to 20 pi. That is f is equal to 20 pi divided by 2 pi. This is equal to 10 hertz. The next question is, if a greater than 0, then function f of x is equal to ax square plus bx plus c has the minimum value at. So here f of x is equal to ax square plus bx plus c. So f dash of x is equal to d by dx of ax square plus bx plus c. This is equal to 2ax plus b. To find the critical point, we can write f dash of x is equal to 0. That is 2ax plus b is equal to 0. 2ax is equal to minus b. That is x is equal to minus b by 2a. To confirm it is maxima or minima, we need to find the double derivative. That is f double dash of x is equal to d by dx of 2ax plus b, that is equal to 2a, which is greater than 0. So we can say that f of x has the minima at x is equal to minus b by 2a. The next question is, assume that the X-rays having the wavelength lambda are incident on a crystal at a glancing angle theta. The spacing between the principal planes of the crystal is d. The condition for the Bragg scattering of X-rays from the crystal is dash. We know the Bragg's condition, that is 2d sin theta is equal to n lambda. So this is the answer. The next question is, an X-ray tube operates on 3 kilovolt. The shortest wavelength of the X-rays produced is dash. We know lambda minimum is equal to Hc divided by Ev, that is equal to 12370 angstrom. Volt divided by volt, that is equal to 12370 angstrom divided by 3000 volt, that is equal to 4.123 angstrom. The next question is, which of the following is incorrect? We know that the Raman lines in the vibrational spectrum are typically equal spaced with a characteristic frequency shift delta nu corresponding to the vibration mode of the molecule. The Stokes and anti-Stokes line appear symmetrically around the Rayleigh line with the equal spacing. Therefore, the statement option D is the incorrect statement. Then option A says the Raman scattering is an inelastic scattering. This is correct because the Raman scattering involves an exchange of energy between the incident photon and the molecule, causing a change in the photon frequency. It is a definition of the inelastic scattering. So the statement is correct. Then option B, the Stokes line corresponds to the transition where the molecule gains energy and the scattered photon has the lower frequency than the incident photon. So this statement is also correct. Then option C, anti-Stokes lines corresponds to the transition where the molecule loses energy and the scattered photons has the higher frequency than the incident photon. So this statement is also correct. So here the incorrect statement is option D. Next question is, assume that monochromatic light is incident at the air glass interface of a glass plate having refractive index n is equal to 1.55. What should be the angle of incidence for the reflected light to be fully polarized? So the tan theta b, that is a Brewster's angle, is equal to n2 by n1. Here n1 is the refractive index of air and is approximated as 1, and n2 is the refractive index of glass, which is 1.55. So tan theta b is equal to 1.55 divided by 1, that is theta b is equal to tan inverse of 1.55. So the angle of incidence for fully polarized reflected light is theta is equal to tan inverse of 1.55. The next question is, a 180 centimeter tall person stands in front of a vertically mounted plane mirror. What should be the minimum length of the mirror to view the entire length of its body? So to view one's entire body in a plane mirror, the minimum height of the mirror required is half the person's height. This can be understood by the law of reflection. The light rays from the top of the head and the bottom of the feet must reflect off the mirror and reach the viewer's eye. So for a person who is 180 cm tall, the minimum length of the mirror required is mirror length is equal to person's height by 2. That is equal to 180 cm by 2, and this is equal to 90 cm. The next question is, when light suffers reflection at the interface from air to glass, the change in phase of the reflected light is equal to dash. So when the light reflects from a boundary with a medium of higher refractive index, that is the glass from air, there is a phase change of pi radians, that is 180. So here the answer is 180. So if the reflection occurs from a boundary with a medium of lower refractive index, then there is no phase change. But here it is asking about the reflection from the medium of higher refractive index. So here the phase change is 180 degree. Next question is, two spheres of the same material have radii 1 meter and 4 meter and the temperature 4000 Kelvin and 2000 Kelvin respectively. The ratio of the energy radiated per second by the first sphere to that by the second is dash. So here P1 by P2 is equal to E sigma 4 pi R1 square T1 raised to 4 divided by E sigma 4 pi R2 square T2 raised to 4. That is equal to R1 by R2 raised to square into T1 by T2 the whole raised to 4. Here R1 is equal to 1 meter, T1 is equal to 4000 Kelvin, R2 is equal to 4 meter, T2 is equal to 2000 Kelvin. So this is equal to 1 by 4 the whole square into 4000 divided by 2000 the whole raised to 4. That is equal to 1 by 4 the whole square into 4 by 2 the whole raised to 4. That is P1 by P2 is equal to 1. So P1 is to P2 is equal to 1 is to 1. The next question is, assume that the parcel of dry air in the atmosphere is ascending adiabatically, then its temperature will dash. So when a parcel of dry air ascends adiabatically in the atmosphere, it expands because the surrounding atmospheric pressure decreases with altitude. So this expansion causes the air parcel to cool down. The rate at which the temperature of the dry air parcel decreases with the increasing height under adiabatic condition is known as the dry adiabatic lapse rate, that is DALR. The value of DALR is approximately 9.8 degree Celsius per kilometer or 9.8 Kelvin per kilometer. So the answer is decreases at a rate of 9.8 Kelvin per kilometer. The next question is, if a baseball is hit exactly with the same force each time, in which situation will the ball travel the farthest? Ignore wind and other effects that are not stated in the answers. So here the answer is warm and moist air, because the distance a baseball travels depends upon air density. Air density is lower in warm and moist air than in cold and dry air. Since there is less air resistance in the less dense air, we can say that the ball will travel farther. So the answer is warm and moist air. Next question is, the skin depth of a good metal for the microwave frequency follows the relation. The skin depth of a good conductor is delta is equal to square root over 2 divided by omega mu stigma, that is equal to square root over 2 divided by 2 pi f stigma mu. Here we can say that omega is the angular frequency, mu is the permeability, stigma is the conductivity of the material. So skin depth is proportional to 1 by square root over f. That is, delta is proportional to 1 by f raised to 1 by 2. Next question is, a 10 meter long string will break under a load of 50 kg. A mass of 1 kg is attached to the end of the string and is moved in a horizontal circle. The greatest number of rotations per minute which the string can have without breaking is nearly dash. Here tension T max is equal to m into g, this is equal to 50 into 9.8, this is equal to 490 Newton. When 1 kilogram mass moves in a horizontal circle, the tension in string provides the centripetal force Fc. When tension is maximum, the greatest number of rotation occurs. That is, Fc is equal to T max, that is equal to 490 Newton. That is, Fc is equal to m omega square r. That is, 490 is equal to 1 kilogram into omega square into 10 meter. That is, omega square is equal to 490 divided by 10. That is, omega square is equal to 49. That is, omega is equal to 7 rad per second. So if it convert into RPM, we can write this as 60 second by 1 minute into 1 rotation by 2 pi radian into omega. That is 60 second into 7 by 2 pi. This is equal to 420 by 2 pi. This is equal to 66.845 and this is approximately equal to 67 RPM. The next question is, the heater element in an electric heater has a resistance of 80 ohm at room temperature. When the heater is connected to a 230 volt power supply, the current settles to a steady value of 2.3 ampere. What is the steady temperature of the heater? The temperature coefficient of resistance of the heater element averaged over the temperature range involved is 2.5 into 10 power minus 4 degrees Celsius raised to minus 1. Here R is equal to V by I, that is equal to 230 volt divided by 2.3 ampere, this is equal to 100 ohm. And we know R is equal to R0 into 1 plus alpha into T minus T naught, that is R minus R naught is equal to R0 alpha into T minus T naught, that is T minus T naught is equal to R minus R naught divided by R0 alpha. This is equation number 1. We know R is equal to 100 ohm, R0 is equal to 80 ohm, T0 is equal to 30 degrees Celsius, alpha is equal to 2.5 into 10 power minus 4 degrees Celsius raised to minus 1. So equation number 1 implies T minus 30 degrees Celsius is equal to 100 minus 80 divided by 80 into 2.5 into 10 power minus 4. That is T minus 30 is equal to 20 divided by 0.02 is equal to 1000 degrees Celsius. That is T is equal to 1000 plus 30, that is equal to 1030 degrees Celsius. Next question is, a star moves with respect to Earth such that the sodium line at 589.0 nanometer is observed at 589.6 nanometer when viewed from Earth. What is the speed of the star in the line of sight? That is delta lambda is equal to lambda minus lambda 0. This is equal to 589.6 minus 589. That is equal to 0.6 nanometer. That is delta lambda by lambda 0 is equal to V by C. That is V is equal to C into delta lambda by lambda 0. This is equal to 3 into 10 power 8 into 0.6 nanometer divided by 589 nanometer. This is equal to 305602.7 meter per second. This is equal to 306 kilometer per second. So since the observed wavelength is longer than the original wavelength, this indicates the redshift, means the star is moving away from the Earth. So the answer is 360 km per second and it is moving away from Earth. The next question is, a long wire along the axis of a long solenoid carries a current of 100 ampere. The field due to the solenoid is 0.05 Tesla. What is the resultant field at a point 1 millimeter from the solenoidal axis? Here the magnetic field of wire is equal to mu 0 I divided by 2 pi r. So the resultant magnetic field is equal to square root over B solenoid square plus B wire square. B wire is equal to 4 pi into 10 power minus 7 into 100 divided by 2 pi into 0.005, and this is equal to 0.004 Tesla, that is equal to 4 milli Tesla. B solenoid is equal to 0.05 Tesla, this is equal to 50 milli Tesla. So B resultant is equal to square root over 50 square plus 4 square. This is equal to square root over 2500 m square t square plus 16 m square t square. And this is equal to 50.1597 milli Tesla, and this is equal to 50.2 milli Tesla. The next question is, consider a parallel plate capacitor separated by an air gap of 4 mm. Calculate the area needed for each plate in order to store energy of 5.5 millijoule when connected across a 5 kilovolt source. So here A is equal to CD by epsilon 0. We know U is equal to half CV square, that is C is equal to UV by C square. Substituting this in the equation of area, that is equal to 2UD divided by epsilon 0 V square. This is equal to 2 into 5.5 into 10 power minus 3 into 4 into 10 power minus 3 divided by 8.854 into 10 power minus 12 into 5 into 10 raised to 3 the whole square. This is approximately equal to 0.1988 meter square. This is equal to 1988 centimeter square. So this is approximately equal to 2000 centimeter square. The next question is, two coils close to each other have mutual inductance 2 millihenry. If the current in the first coil at a given time increases at a rate of 1.6 into 10 power 3 ampere per second, what would be the voltage induced across the other coil at that time? So here M is equal to 2 millihenry. This is equal to 2 into 10 power minus 3 henry. And di by dt is equal to 1.6 into 10 power 3 ampere per second. So by Faraday's law, V is equal to minus M di by dt. This is equal to minus 2 into 10 power minus 3 henry into 1.6 into 10 power 3 ampere per second. And this is equal to minus 3.2 volt. Next question is, the maximum value of magnetic field measured at 5 km distance from the antenna of a radio station is 0.5 nt. What would be the power radiated assuming that the antenna radiates spherical waves? Here B0 is equal to 0.5 nt, that is equal to 0.5 into 10 power minus 9 Tesla, and R is equal to 5 km, this is equal to 5000 meters. C is equal to 3 into 10 power 8 meter per second, and mu 0 is equal to 4 pi into 10 power minus 7 Tesla meter per ampere.
So here I is equal to E0 B0 by 2 mu 0. This is equal to C B0 square by 2 mu 0, where E0 is equal to C B0. So this is equation number 1. Power P is equal to I into A. This is equal to I into 4 pi R square. This is equation number 2. So we can write equation number 1 as I is equal to C B0 square divided by 2 mu 0. This is equal to 3 into 10 power 8 into 0.5 into 10 power minus 9 the whole square divided by 2 into 4 pi into 10 power minus 7. This is equal to 2.984 into 10 power minus 5 Weber per meter square. So here power P is equal to I into 4 pi R square. This is equal to 2.984 into 10 power minus 5 into 4 pi into 5000 square. This is equal to 2.984 into 10 power minus 5 into 4 pi into 25 into 10 power 6 watt. And this is equal to 937000 watt. That is equal to 937 kilowatt. Next question is, an astronaut takes a trip to nearby star which is located a distance of 10 light years from the earth. If the spaceship moves at a constant speed of 0.8 c, what would be the trip time measured by the astronaut for one-way journey, where c is the velocity of light? So here L0 is equal to 10 light years, V is equal to 0.8 c. We know by time dilation delta T0 is equal to delta T into square root over 1 minus V square by C square, and delta T is equal to L0 by V, that is equal to 10 light years divided by 0.8 c, and this is equal to 10 c into 1 year divided by 0.8 c, and this is equal to 10 divided by 0.8 years, and this is equal to 12.5 years. Delta T0 is equal to 12.5 into square root over 1 minus 0.8 c square divided by c square years, and this is equal to 12.5 years into square root over 1 minus 0.64 c square by c square, and this is equal to 7.5 years. Next question is, a person enters an AC room that is maintained at 18 degrees Celsius. If the skin temperature of the person is 35 degrees Celsius and unclothed, skin area is 7.5 into 10 power 3 centimeter square. Find the approximate net energy lost by radiation in 15 minutes. Assume emissivity of skin as 0.9. Here T skin is equal to 35 degrees Celsius, and this is equal to 35 plus 273 is equal to 308 Kelvin, and T room is equal to 18 degrees Celsius is equal to 18 plus 273, that is equal to 291 Kelvin. Here area is equal to 7.5 into 10 power 3 centimeter square. This is equal to 7.5 into 10 power 3 into 10 raised to minus 4. This is equal to 0.75 meter square. Here T is equal to 15 minutes, and this is equal to 15 into 60. This is equal to 900 seconds. And here E is equal to 0.9, and sigma is equal to 5.67 into 10 power minus 8 watt per meter square Kelvin raised to 4. Here P net is equal to EA sigma into T skin raised to 4 minus T room raised to 4, that is equal to 0.9 into 0.75 into 5.67 into 10 power minus 8 into 308 raised to 4 minus 291 the whole raised to 4, and this is equal to 68.96 watt. Here energy loss E is equal to P net into T, and this is equal to 68.96 into 900, and this is equal to 62064 joule. This is equal to 62.064 kilojoule. Next question is, a balloon having volume 4000 meter cube and mass 3000 kilogram is filled with helium. If the density of air is 1.2 kilogram per meter cube and the helium gas having density 0.18 kilogram per meter cube completely fills the balloon, what is the maximum mass of the load that can be lifted by the balloon? So here Bion force FB is equal to V into rho air into G. So this is equal to 4000 into 1.2 into 9.8, and this is equal to 47040 Newton. M helium is equal to V into rho helium, that is equal to 4000 into 0.18, that is equal to 720 kilogram, and M total is equal to M balloon plus M helium, that is equal to 3000 plus 720, this is equal to 3720 kilogram. M lift is equal to F Bion by G, that is equal to 47040 divided by 9.8, and this is equal to 4800 kilogram. M load is equal to M lift minus M total, that is equal to 4800 minus 3720, this is equal to 1080 kilogram, that is equal to 1.08 into 10 power 3 kilogram. The next question is, two pendulums whose length differ by 22 centimeter oscillates at a given place. One of them makes 30 oscillation and the other 36 oscillations during the same time. The length of the pendulum r dash. We know T is equal to 2 pi square root over L by G. T1 by T2 is equal to 2 pi square root over L1 by G divided by 2 pi square root over L2 by G. And this is equal to square root over L1 by L2. This is equation number 1. We know T1 is equal to T by N1. This is equation number 2, where N is the number of oscillations in time T. T2 is equal to T by N2. This is equation number 3. Substituting these values in equation number 1, we can write T by N1 by T by N2 is equal to square root over L1 by L2. We know N1 is equal to 30, N2 is equal to 60. That is T by 30 divided by T by 36 is equal to square root over L1 by L2. That is 36 by 30 is equal to square root over L1 by L2. That is 6 by 5 is equal to square root over L1 by L2. Squaring, we get 36 by 25 is equal to L1 by L2. That is L1 is equal to 36 by 25 into L2. This is equation number 4. Given that L1 minus L2 is equal to 22, this is equation number 5. Substituting the value of 4 and 5, we get 36 by 25 L2 minus L2 is equal to 22. That is L2 into 36 minus 25 minus 1 is equal to 22. That is L2 into 36 minus 25 by 25 is equal to 22. That is L2 into 11 by 25 is equal to 22. That is L2 is equal to 50 centimeter. L1 minus 50 is equal to 22 centimeter. That is L1 is equal to 72 centimeter. So the answer is 50 centimeter and 72 centimeter. The next question is the de Broglie wavelength of an electron accelerated through the potential of 150 volt is dash.
We know lambda is equal to h divided by square root over 2 me ev, and h is equal to 6.626 into 10 power minus 34 joule second. Me is equal to 9.1 into 10 power minus 31 kilogram. E is equal to 1.6 into 10 power minus 19 coulomb. Substituting all these values, we get lambda is equal to 12.27 divided by square root over V Armstrong. Here V is equal to 150. That is lambda is equal to 12.27 divided by square root over 150 Armstrong. And this is equal to 1.004 angstrom. The next question is the white light with the uniform intensity across the visible wavelength range is incident on a water film of thickness 320 nanometers suspended in the air. Refractive index of the water film is 1.33. At what wavelength is the light reflected by the film brightest to an observer? Here we know that 2nt is equal to m plus half into lambda, and lambda is equal to 2nt divided by m plus half. T is equal to 320 nanometer, n is equal to 1.33, and for m is equal to 0, lambda 0 is equal to 2 into 1.33 into 320 nanometer divided by 0 plus 0.5, and this is equal to 1702.4 nanometer. So this wavelength is outside the visible spectrum. We know that the visible light has a wavelength in the range of 400 nanometer to 700 nanometer. So this wavelength is outside the visible light spectrum. So we take the next value of m, that is for m is equal to 1, lambda 1 is equal to 2 into 1.33 into 320 divided by 1 plus 0.5, and this is approximately equal to 567.5 nanometer, and this wavelength is within the visible spectrum. That means the wavelength is between 400 nanometer and 700 nanometer. So the answer is lambda is equal to 567.5 nanometer. The next question is a convex lens of 32 mm diameter and a focal length of 24 cm is used to form images of objects. Considering refraction of lens, what angular separation must two distant point objects have to satisfy Rayleigh creation? The wavelength of the light from the distant object is 550 nanometer. So here d is equal to 32 millimeter, this is equal to 32 into 10 power minus 3 meter. Lambda is equal to 550 nanometer, this is equal to 550 into 10 power minus 10 meter. We know that theta is equal to 1.22 lambda by d, this is equal to 1.22 into 550 into 10 power minus 10 divided by 32 into 10 power minus 3. And this is equal to 1.22 into 550 by 32 into 10 power minus 6 rad, and this is equal to 1.22 into 17.1875 into 10 power minus 6 rad, and this is equal to 20.97 into 10 power minus 6 rad. This is approximately equal to 2.1 into 10 power minus 5 rad. So this is the answer. This is the end of this video. Thanks for watching this channel.